jump up. We start off by producing a file on Circuit Wizard. On Circuit Wizard, we go to the PCB layout facility, or the tab, and what we do is we produce this design. Once we've done that, we go to what's called artwork, and that will give us a black and white image that we need to send to the printer. How do we send it to the printer? Well, we go to File, we go to Print, Current Design. When we go to Print Current Design, we go to Properties. And on Properties, we go to Paper Source. And we must select the multi-purpose tray, okay? It's really important. Once we've selected the multi-purpose tray, what we do is we press OK, and that will be sent through. Can I have your card, please? Where is he? Where is he? Okay, now we're going to go to the photocopier. Can I have your card, please? Thank you. So off we go to the photocopier. Well, let's go. Ready, so the machine comes to turn on, or someone doesn't see it. Alright.
Mad. So where are you? Are you off to?
Where am I?
Okay.
So guys, here we are at the photocopier. And what we need to do is get ourselves a piece of transparency. Now transparency is usually in this box here, okay? Somebody's taken this out, probably James Callahan. And so we're going to get a piece of this out, and we're going to open up the feeder on the photocopier. When that comes up, can you just have a look at this screen? Okay, this screen appears and we press OK. I think that probably was wrong. I'm going to sign in, and what I'm going to ask, actually I'll do it. I'm just going to pull that back, and we're going to push that back in.
It's gone over this one.
No, don't touch it.
It's gone over one of the things which is on there, going over this one.
Okay, right. We're going to go to change, and we're going to put down transparency. Can you see that? We're going to select transparency, and we're going to press OK. We're going to press OK again, and then we're going to go to print, and we're going to go to the Circuit Wizard file, and we're going to print it. And what should happen is it should take our transparency from there, yep, and it should print us a nice circuit design onto that. Okay, so what do we get? We've got our lovely circuit design, all right, from Christopher. Everyone understands so far? Right, we're going to go back to DT7 now, so off we go. Quick, come on. Aluminium, steel. It's all the centimetre because in here we have our chuck, which goes open and close. Here is the chuck. Right, guys. Next up, we will go around the table here.
Oh no, we don't.
Guys, come on the table here.
It's not very fine. It's not very fine.
Ryan, you alright?
Yeah.
We're going to get ourselves some scissors, and we're going to cut one of these out. Really simply. Going to cut it out with a pair of scissors. Try not to get too much of our fingers. All over the image. So we've cut that out. Next up, we want to cut this down, and so it's the correct size. So I'm just going to take your, is it a pen or a pencil?
Pen.
I'm going to take a pen and I've marked this piece of PCB so that I know whereabouts I'm cutting. I'm going to get our guillotine that we've used before, and I'm going to put this. Can you stop singing, please? Okay, I'm going to put this into the guillotine so I can see where I'm cutting, and I'm going to chop down. And so now I've got a piece which is exactly the right one. Exactly, it's a really good size. Okay, next up, we are off to the, what is it called? The UV box, which is over in the corner here. Guys, come over. I'm sorry, it's a bit messy around here. We need to get it looking clearer. Can you see on the UV box, it's got 90. That is 90 seconds, okay? The next thing we need to do is expose that image onto our piece of PCB. Now, you remember what I said? It's got a piece of glass fibre, then it's got a copper layer, then it's got that photoresist layer, and then it's got this blue layer, which just is really opaque, which stops any light getting through. So what we're going to do is we're going to peel this off. We're going to place our mask on it, and so the writing is the right way round. It's really important. We're then going to open up. We're going to open up and we're going to put this into the middle. I've actually done this a little bit wrong in actual fact. What I should have done before that is turned this on for about 1 minute to let those bulbs heat up and warm up. They take a little bit of time to warm up, and so you won't get full brightness if I was to expose right now. So you wait about a minute. After a minute, you then turn it off. You then put your mask in, you put your piece of PCB in, and then you do your 90 seconds, okay? So 90 seconds to develop your image onto your piece of PCB. Everyone understand? Right, once we've done that, we take this out. Often what I suggest you should do is put that onto your hand like that, so no more light, no more UV rays can get to it. Okay, we've had the UV from the box exposing it, but we don't want any more. Then we go over here.
So do you need the...
We actually have some solution here that's been made out. The solution that we've got is, actually we don't have any in at the moment, we're just ordering some more in. It's some concentrated solution. And we've got to water it down. We've got to water it down 1 to 20, okay? So generally what I say is we get a little syringe and we get 5 millilitres of the concentrate solution, and we get how much of water? 100 of water, yeah. And we've got this little jug here, so we get 100 of water, we get 5 millilitres of the solution, we put it into this little plastic piece of Tupperware here, and give it a good mix around, okay? Give it a good mix around so it's all mixed. What I should have said at this point is we put safety goggles on, and we also wear an apron. I would try and get one of these plastic aprons so that none of these chemicals go on your clothes. Is that clear? We also get nitrile gloves, which are these here, nitrile gloves, and they will protect your hands as well. Okay, so we've got nitrile gloves, we've got goggles, and we've also got an apron on. Are you all clear? We've also got our mixed solution here. Agreed? What you do is you put your piece of PCB into this, and what will happen as you rock this backwards and forwards, over about a minute, I would say, about a minute, you'll start to wash away those areas that have had the UV rays exposed to them, okay? So any area that's been exposed to UV rays will wash off. What do you get now? Well, you don't get a finished circuit board. You don't get something, can you see this is an awful circuit board? You don't get something like that. You get something a little bit more like that. And can you see that's still got the copper in between the tracks? Are you with me? So what do you need to do next? Well, we need to try and get rid of that copper. So once we've done that, can you all move back about 2 paces, please? We need to go to the etching machine. Now the etching machine is here. The etching machine needs to heat up to 42 degrees. And so if I was to turn this on now, it's probably going to be about 20 degrees or so. Let's wait, it's on 32. I'm pretty, someone's obviously had this on. That'll be about room temperature, about 20 degrees, depending upon what time of year. And what we need to do is wait for that to heat up to 42 degrees. Around 42 degrees is when it's most effective, where the acid from here etches in the most efficient way. So we turn that on. Once that's on, and we're happy, we then get out the holder, all right? The holder is here. Now, the way the holder works is I would always try and get, you see this bottom bar, I try and get it parallel with the bottom here. All right, that was a little bit like a diagonal. All right, okay. Now, Alton, can you put your finger in there? Can you feel in there? Can you feel there's a ridge?
Yeah.
Yeah? That ridge is so that we can put our PCB in that ridge and it holds it nice and firmly. I then would undo, with my fingers, I would undo the nuts, the other side, and I can bring it on top of it. Alright, and I can do that up. Alright, so that holds it nice and firmly. Are you with me?
Yep.
Once we've done that, what we do is we wait until this is 42 degrees. When that's 42 degrees, we open this, and inside this is something called ferric chloride. When ferric chloride gets in your clothes, you can't get it out. You can see it's loads of ferric chloride that's been spilt around here. Alright, so you've got to be very careful. I put it in the machine, and what I would do now is I'd turn it on. And I'd turn it on for about 2 minutes, alright? When I turn it on, as I press this button which says U, okay? Just by those 2 minutes, it's that button which says U. I turn that on, and it goes, the motor spins a propeller, and that projects lots of acid onto that PCB. Alright? As it goes, that hot acid then washes down and it takes away the copper. Right? It's what's called a jet acid etching machine. Alright? And once we've done that, after 2 minutes, what we do is we open this, and what we don't do at this point is take it over to the sink. We will put it straight into here and we'll wash it off. How do we wash it off? You can see there's another button here, which is the rinser. Okay? And that will rinse off all the ferric chloride. Okay? So now we've rinsed off the ferric chloride, this is all wet. We have a look at it and we assess it over the sink, and we think, is that good enough? Maybe it needs some more time. We might then want to put it back in here, okay, and put it on for another 30 seconds, maybe another minute, maybe another 2 minutes. But generally, you might need another 30 seconds. Are you clear so far? What do we end up with? We end up with something, hopefully better, something like this, where you can see the tracks, and behind the tracks, what you can see is that we've got that greeny sort of look, which is a glass fibre, the same colour as the back. Are you all with me? Right. So, I'm going to take this out because we don't need this. I'm going to put that back in there. Of course, once you finish with this, you just leave it on the side here like this, don't you? Oh, turn just like that, yeah? No, where'd you put it? Thank you very much. You put it back in here. And what you make sure is you've tidied up around here, and we're all happy, and we haven't left anything out, like this person here. And we've got our circuit board, which has the design cut into it now, acid etched into it. What do we do next? Well, I'm going to ask you to move back probably about 3 or 4 paces. We go over to the drills. That's not true. That's not true. Just stand there. Over here, you should find. No, I can't do it. Usually over here we have a tray which has wire wool in it. Okay, wire wool. It should be labelled with wire wool in it. What you have is you have your copper tracks, but what's on top of the copper tracks?
Oh, the film.
The film, that photoresist, and that's a plastic. So if I was to put a component onto that, try and solder onto that, I'd be soldering onto the plastic. So we want to get rid of that. The way we get rid of that is we get another piece of wire wool and we just go over the surface, and it's a shame there's none here. I'll see what I'm going to do. I'm going to pop and get some, so I want to show you something else. So you stay there.
Guys, we get a film. What are you making?
No, me and
Should I just put it on the table?
We have the 6 pounds.
Okay, so this is what I was talking about, the wire wall, steel walls. It's called two different things. Can you see it? Now, if you come and look at this, guys, you were saying this is a copper colour, and I was saying, no, it's not a copper colour. And you can see that very well when I start to scratch away and I get rid of that photoresist layer. You can see now that that is a bright copper colour, and that's the copper you want to be soldering to. So once you've got rid of all that photoresist, you've got a nice design on here. The last thing you want to do is go over to this area here where we have the drill set up, and you're going to be drilling. Oltan, no man, come on, no talking. You're going to be drilling holes in the areas that need drilling so your through-hole components can be soldered. Does that make sense? All right, go. All right, Ryan, can you please press stop?